Good afternoon, everyone. I'd like to welcome you to the official opening ceremonies of the annual meeting of the Cognitive Neuroscience Society. I'm Michael Anderson, and I'm the program chair of this year's meeting. As those of you who attended this afternoon's session on both the past and the future of cognitive neuroscience will attest, this meeting is a very special meeting for us. It's our 30th anniversary. It's the big 3-0. And so we decided that it was entirely fitting and appropriate for us to celebrate that with an extra special meeting. So the various committees involved in organizing this conference put a lot of effort into organizing a special proceedings for you. And this includes, of course, lectures from various luminaries in the field, both current and potentially future luminaries, like tonight's speaker, Martha Farah, as well as award addresses from Sabina Kastner, Mark Desposito, and Anna Shapiro. And we're especially proud of our lineup of invited symposia as well. We do hope that you'll partake of those and enjoy the cutting edge science that's being presented in each. So my thanks to my colleagues involved in the various elements of organizing this conference. Thank you very much. And of course, it goes without saying that none of this would be possible without the generous support of our sponsors, which I'll mention here, the Kavli Foundation, the Chen Institute, the Journal of Cognitive Neuroscience, UCSD School of Social Science, Frontiers in Cognition, and MIT Press. Thank you very much indeed for your generous support, which will enable the many successes of this conference. Some practical announcements that are important. Immediately after this keynote lecture, there will be a welcome reception in the atrium from 6 until 7, that is to say the lobby. There'll be a brief break between 7 and 8 o'clock, and then from 8 until 11, there'll be the 30th anniversary dance party. So let's get your groove on, come on down. From 8 until 9:30, there'll be a local DJ, and then the real action starts. 9:30 to 11, Pavlov's dogs. And if you haven't seen him before, come see him. It's a lot of fun. You'll really enjoy it. For those of you who don't know who that is, no, it's not a bunch of dogs that we're going to be showing you. It's a group of cognitive neuroscientists in a rock band. So pretty cool. It's my distinct pleasure to introduce tonight's keynote speaker, Martha Farah. She's the Walter Annenberg Professor of Natural Sciences at the University of Pennsylvania, and of course, a leading figure in the field of cognitive neuroscience. Everyone in this room will be familiar with Martha's work, but you might not be familiar with the ins and outs of her personal history. So she did her undergraduate degree at MIT, where she majored in philosophy and metallurgy, I learned. She got her PhD in psychology from Harvard University. It was on the faculty at Carnegie Mellon University, as well as the University of Pennsylvania. Martha's work has touched on a dizzying array of the most fundamental issues in our field. She's done work on mental imagery, face perception, semantic memory, reading, executive function, and more recently, a lot of her work is focused on poverty and its impact on brain development, which we'll hear a little bit more about tonight, as well as neuroethics. She is the director for the Center of Neuroscience and Society at the University of Pennsylvania, and the recipient of the Lifetime Achievement Award from the Association for Psychological Science. And just a few words about the basis on which we chose Martha to be this year's keynote speaker, it being a very special Cognitive Neuroscience Society meeting after all. And of course, there are many excellent reasons for choosing Martha. But it was not simply because she's a model of rigorous, careful, and insightful and thoughtful research, which of course she is. And it's not simply that she's produced some of the classic articles in the field that we all know and love, which she has. And it's not because merely because she's a fantastic speaker and a very engaging speaker, which of course she is, but rather because I think she exemplifies what each of us should aspire to be as cognitive neuroscientists, to conduct research that is at once well done, rigorous, thoughtful, and research that matters to human beings and to society at large. Research that has the potential to result in translation in terms of policy that impact the lives of everyday people. And if each of us had half the reach and half the vision that Martha has exhibited throughout her career, our field would be a force to be reckoned with in society. Please join me in welcoming Martha Farah.
Oh, Michael, thank you so much for that kind of over-the-top introduction. I'll try to live up to it, probably won't. Thank you also, CNS in general. I will say, knowing that this is the 30th anniversary meeting makes me feel very old because I was there for the first one. And I wasn't a toddler either. Okay. So what I want to do is start with a little background on how and why I started to work on this topic. Now, again, referring to how old people are, some of you may remember the Hanna-Barbera animated version of Alice in Wonderland. So much cooler than the Disney one. And the Cheshire Cat was voiced by Sammy Davis Jr. And the song was, "What's a nice kid like you doing in a place like this, Wonderland?" Well, the question I sometimes ask myself is, what's a nice cognitive neuroscientist like you doing with a topic like socioeconomic status? Well, friends, I was once a happy vision researcher. As such, I could design experiments that would isolate and deconfound various variables of interest. I could even design experiments, manipulations that would answer questions about causality, what is responsible for what. And nobody ever told me I was an evil eugenicist for the work that I do. Alas, I left all that behind because I got to know 3 families, all of very low socioeconomic status, and learning about their lives was like, going through the looking glass. I could talk for hours about the ways in which their lives were different, but I won't. Suffice to say, they had, insecure jobs, lived in neighborhoods where they were frequently victims of crime. What are some of the other things on my list of miseries? They had little control over their lives in general. And their kids, almost invariably, and I realize when we're talking about groups of people, we have to realize things aren't always categorical, but almost invariably, their kids, low SES kids, start their schooling, start kindergarten, substantially behind in pre-academic skills, compared to their higher SES counterparts. I could go on and on, but I won't. Instead, I'm going to give you a different way of understanding how I experienced this, revelation of this chunk of society, these many, many fellow citizens that I didn't know anything about and discovered how foreign their lives were. As an academic, like many of you, I've had the opportunity to travel far and wide, and I've actually had the pleasure of staying in people's homes in Asia, in the Middle East, South America, where else? Europe, that's boring these days, and of course, these were all middle-class families, right? They were other academics, but the lives that I saw there didn't differ in any really hard to grapple with way from mine, from ours. In contrast, the culture shock that I experienced going and having dinner with people in their home, a couple of miles north of where my home is in Philadelphia, was huge. It was really like, again, going through the looking glass. So today I'm going to talk a little bit about my own research, which is basically, this phenomenon clobbered me, and I had to understand it. My one tool, the one thing that I knew how to do, was cognitive neuroscience. So I set about on a program of research with various wonderful collaborators and students. I'm not going to take the time to list them, but certainly this is not, a one-person shop. And what I'm going to do is I'll tell you a little about my research. I'll tell you some about other people's research. And I will spend most of the time asking the question, can cognitive neuroscience be put to use for reducing the harms of poverty? Is it useful, or is it as pointless as giving, okay, the proportions of these slides, we still didn't quite get it right, but as pointless as giving a fish a bicycle? Hence the talk of this, the title of this talk. Okay, so first, a little background on the fish in question. SES, you probably know, is a continuum. It's not just like poor or not poor. And it consists of, can you all see the print up there? And if the people in the front row are going, I don't know what happened. It's very, very weird. Anyway, well, okay, so, I'm having trouble seeing it on the screen here too. Socioeconomic status is usually measured, estimated by a collection of moderately correlated factors, including, obviously, income, wealth, educational attainment, occupational status, neighborhood characteristics, etc. And why is SES important? Well, here we go. Oh, wait, that's the wrong segue. Furthermore, I want to say that poverty, when I use that word, I'm referring to the very low end of SES that's typically discussed in terms of money. So the US poverty line is defined by an income to needs ratio. The more mouths you have to feed, the more money you need to be above the poverty line. In 2022, it was almost $28,000 a year for a family of 4. So graduate students and postdocs, imagine trying to feed 4 mouths, keep them clothed, etc., on what's probably less than what you're making. Poverty per se, the low end, is the most harmful. But the interesting thing about SES, which I don't think anybody really understands, is that it does have a graded effect even beyond poverty. So why does it matter? Well, it's linked to, oh God, I don't know what happened to my slides, but apologize. At least you get the sort of low spatial frequencies here. You can kind of see that there's something going down. it's linked to mental health and cognitive ability. So this bar chart shows the results of a Canadian, province of Ontario public health study showing the rate of the percentage of the population meeting diagnostic criteria for major depression in the past year. Okay, not lifetime, past year. And it arrays that information from the lowest decile of income to the highest. And even without reading the axes, you can see this is a big effect. If you're in like the lowest, if you're in the highest third of income, you have approximately 1/3 the rate of major depression as people in the lowest 10%. Think about, we're rightfully concerned with sex differences in the incidence of depression, but it's not a factor of 3, right? So this is, an understudied and socially very important phenomenon. Okay. In addition to mental health, you can see what's here is data from ETS, SAT scores, as a function of income, low income again on the left. And you can see that, the higher the income, the better you do on your SATs. They're sometimes called the scholastic affluence test. And, there's differences, of a standard deviation or more between the low and the high end. Okay, so why is this relevant to us who have gathered here? Because mental health and cognitive ability is linked to the brain. So SES is linked to the brain, and maybe we could figure something out by approaching it with neuroscience. Okay, so now I'm going to give you a flyover at 35,000 feet of the neuroscience of SES. Okay, totally inadequate, overly abbreviated, whatever, but it'll give you a flavor. So, first of all, oh my God, you should all have like opera glasses. Anyway, so the first line says, structural and functional correlates of SES. Okay, they exist. They are relevant to SES-linked differences in psychological outcomes, cognitive performance, emotional well-being, etc. Interestingly, the relationship is not always simple. It's not just, the more activity you have in this spot, the better you do, and that accounts for the SES difference. There are, I won't say a lot of cases, but enough cases to think it's not a fluke, where SES moderates the relation between brain and behavior. That is to say, lower and higher SES people are carrying out the same cognitive task with different parts of their brain, even when accounting for performance level. It's sort of interesting. Okay, the next thing I want to tell you is that there's an emerging, but still very rudimentary, understanding of causal pathways. Remember, causality, I was, thinking back nostalgically for the days when, in vision you could actually get at causality. And there's lots more to say, which I can't do here now, but, these things change dynamically over the lifespan. There are likely to be sensitive periods where the experiences of SES have more or less of an effect. There are genetic effects. This is why I have been called an evil eugenicist, even though it seems like a non sequitur, but there are issues in this field, like there are in all of our fields, of replicability and all the limits to what you can infer from these kinds of data. Okay, so what, if any, are the real world implications? Well, this has been the subject of debate. Some people, I'll just call them the alarmists, I'm going to give little quotes here, which you probably can't read anyway, but I'll read them aloud to you. These are not actual quotations from anyone's writings. They are sort of ways of conveying the general position that some segment of the literature believes in. Okay, so the alarmists would say things like, this will, finding brain differences will lead to further denigration and dehumanization of the poor as, damaged goods, essentially. I mean, that is a risk. That is a risk. And this kind of work could be used to try to make that point, misused, I should say. There are the enthusiasts who say things like, at last we can look under the hood and see what is preventing low SES children from achieving their full potential, and thereby, design interventions, policies that would be beneficial. And finally, there are the skeptics who say, brains may differ, but this tells us nothing about how to help, or even if help is possible. Okay? Now, I will say, I think, there's a grain of truth in each of these statements, and we're going to look in a little more detail at people who have proposed and defended these positions. Okay. Michael Katz, an historian, has written a lot about social history of poverty, and he has said, you may feel like you're being much nicer if you replace talk of, incompetence, laziness, anti-sociality with talk of, brain differences, deficits in this or that system. But really, you're just saying they're biologically inferior, and that doesn't help much, right? I'm biologically inferior, thanks a lot. Okay. There's neuropolicy enthusiasm, and basically, this involves people who don't know much neuroscience making very general statements about how, we're going to look under the hood and it's going to all be clear. So I'm going to just go through a few of these things very quickly. These are, books on Amazon and so forth. This is a big seller, Teaching with Poverty in Mind. A lot of teachers have it and read it. This is something from the National Education Association, which is a little less factually incorrect. Oh my goodness, I don't know, I can't even read it on my own. Yee. Oh yes, okay. This is some material from the National Center for the Developing Child at Harvard, which does not actually do research on neuroscience. What they do is come up with framing of facts about child development that they think will help persuade policymakers. So they talk a lot about things like, brain architecture and toxic stress. You've heard that term. That comes from this. They've worked with an expert political messaging firm called Frameworks to figure out the most persuasive and helpful ways to get policymakers thinking about this stuff. But it isn't it's persuasion. It's not putting particular ideas to work. This is more from the UK, which has been very enthusiastic about protecting child brain development as a kind of investment in their human capital. This is from a group in Boston that trains poor women to be successful financially and manage their finances, earn money, et cetera. And the talk is all about the brain. I can't even read this print, I'm sorry, but it's things like brain-based approaches to planning, and stuff like that. So that's a quick survey of neuropolicy enthusiasm. Now let's move to skepticism. Okay. Well, we start with a study done or a publication done in the 60s, sort of a notorious publication by Arthur Jensen, who actually started out wanting to intervene and improve the cognitive abilities of poor children. But he couldn't seem to do it and couldn't find anybody else who could, and so he concluded social class variations in intelligence cannot be accounted for by differences in environment. I will just say that's a little bit of a non sequitur, right? It's like, I change the environment and I don't see effects. I change the environment in some finite number of ways and I don't see the effects. So individual differences are not resulting from the environment, maybe, maybe not. Okay, here's a quote from Steve Pinker, who I think is, pretty reasonable and open-minded, and he is irritated by people who point to the neuroscience of poverty and say, well, this shows that, the plastic brain or plastic developing brains are impeded by upbringings in poverty. And what he says, which, might seem, it's not very, dressed up to make it palatable. He says, look, people might inherit genes that make their parents bigger-brained. And the parents are smarter, and hence they're richer, right? So you get raised in an environment that's well off, and you inherit your parents' genes. So that's why big-brainedness and SES are correlated. And, you can't really argue with that. It's a logical statement, and it could be true. Then we have Charles Murray of bell curve fame, who basically concludes class structure is importantly based on differences in abilities that have a substantial genetic component. Interventions are inherently constrained in the effects they can have. So, we're kind of, if it's all genetic, the argument goes, why think that there's anything you can do, right? Again, I think that is a non sequitur, and I will elaborate on that in a minute. But right now, the question raised by the neuroscience of poverty skeptics is, are these SES effects innate or environmental? And does it matter? Well, I'm going to say yes and no, like a typical academic. Yes, because, it does matter if they're genetic, because if the harms that we see manifest, if the disadvantages that we see manifest in the poor are not caused by the environment, then it's not so clear what we should be focusing on to change in the environment to prevent the harms, right? If you can identify, like, okay, here's the problem, lead, or violence causing stress, or whatever, then you can, choose that as a target for intervention. But I would also say no, because plenty of innate disadvantages can be mitigated too. So, if you bring your child to Children's Hospital in Philadelphia with, what is it called? What is the disease where people bleed a lot? Hemophilia, yeah. You have a hemophiliac child and you bring them in, the doctor doesn't say, oh, I'm sorry, but that's a genetic disease, go home, right? There's things you can do. PKU, another, as far as I know, entirely genetic condition. Well, with the right diet, kids born with PKU can live a normal life. So this idea that if it's genetic, then there's nothing you can do is just false. It's not a valid inference. Finally, I want to point out that there is evidence of environmental causation of SES-related brain differences. So one is, this is work from Jean Brody and colleagues reporting the effects of an intervention in adolescents in relatively poor, spanning a range of SES African American families. And the intervention is called Strong African American Families. And what it does is give training sessions to the kids and to the parents, all aimed at creating more confident, comfortable, less stressed kids. And what you see plotted here, again, you see two lines, and that's probably all you can see. But the downward sloping line shows the volume of the hippocampus in the control group as a function of how many years they have lived in poverty. The straight across line shows the hippocampal volume of the intervention group as a function of how many years they've been poor. And as you can see, that intervention blocks the damaging effects of poverty on the hippocampus. Here's another finding, which I'm very grateful to Brad, if he's here, for publishing. We scanned people in middle age who had, as children, been part of the Abecedarian intervention. And I'm guessing some of you know about the Abecedarians, landmark, randomized, very intensive early childhood intervention, starting at just weeks of age and going through age 5. 5 days a week, 50 weeks a year. It was kind of magnificent, very expensive, but then Jim Heckman argues that if we invested that up front, society would save a lot later. What we found is, we then scanned them with Reed Montague and the Ramies, as you see here. Now we found effects of the intervention. These bar charts show differences between control and intervention group. I should mention the controls. This was just a great design. The controls, they thought they were in an intervention group because they got supplementary, formula and facilitated visits to the doctor, to various social services. So it was a very nice contrast that they were able to draw, and it was randomized. Now, oddly enough, the intervention had an effect in the males. It had much less effect in the females. And it turns out sex differences in intervention effects are not uncommon. I have no idea why we found this. Basically, other people also, they say, oh, here's an intervention effect that's only in girls or only in boys. We don't know why. But in any case, you can see these are cortical regions related, we thought, to the nature of the experimental, enrichment, the environmental enrichment that we thought might result in changes. And for the grown-up boys, and in one area for the grown-up girls, it did. Okay, so again, this is an environmental manipulation. Not only that, it's an environmental manipulation aimed at kind of restoring some of the, intensive, high-quality cognitive and linguistic experience that very low SCS families have a lot less of. Okay, one more slide along these lines. This is a study that I did with some colleagues in Amsterdam. They call themselves gene economists because basically they do behavioral genetics using fancy economic models, econometrics and the like. And what we did is analyze the structural MRIs of the UK Biobank, which is tens of thousands of people, and looked to see the distribution of volume differences as a function of SES. Top line is SES differences. Middle line is genetic differences associated with the polygenic score, the polygenic index for SES, computed from everybody who was not in the imaging sample. And then the last line shows what's left over in terms of brain differences as a function of SES when you get rid of the genetic component. So, there's both genetics and things other than genetics, environment. Interestingly, they seem to influence different parts of the brain. Somewhat surprisingly, the most genetic we found was the insula, which might have to do with, the mental well-being and so forth, I don't know. And the most environmental was the cerebellum, which surprised me a lot. But giving a talk to Lynn Nadell recently, he said, oh yeah, the cerebellum, that makes perfect sense. It'll be the neocerebellum. And I was like, well, I don't actually know what part of the cerebellum it is, and I'm looking at this figure and I can't be sure. I checked later, it is. He says that is the part of the cerebellum that is most plastic and whose maturation is most driven by the environment, which is kind of interesting. Okay, moving along. So we've just seen the main reason for skepticism about the usefulness of SES neuroscience is that people say, well, the effects are mainly genetic, even though we know there's actually plenty of variance left in the environmental category. The other main criticism that has been raised was, awkwardly enough, raised by my colleague at the Penn Law School, Amy Wax, who some of you may know about from the news. And she actually, I think, raised an interesting challenge. She said, it's nice to look at these neural correlates and all, but what special insights over and above what we get from behavioral data tells us anything about how to eliminate the harms of poverty? And, okay. So the question is, does neuroscience add anything new and useful? Okay, well, here's the thing. We usually think of great science as about being the first to demonstrate something, right? I mean, that's what gets you on the cover of Science magazine. Not a new demonstration by a different method of something that we knew. It's something unprecedented. But that's the last thing you want to base policy on. You don't want one, stellar finding and change the way you educate children or support families economically, nutritionally, whatever, right? What policy is based on is what's sometimes called the weight of the evidence. And having evidence from different methods, qualitatively different kinds of evidence, is a great boost to the weight of the evidence. And so that's what neuroscience so far has been able to add. I think it may have some more unique contributions to make, but Amy has said, I have said years ago, you don't need a neuroscientist to tell you that stress is bad for children, right? Well, that's true, but if you're going to invest societal resources in measuring stress, lowering stress, et cetera, it would be really good to be certain about that relation of stress and developmental problems. So having another body of knowledge, and of course with neuroscience, we are drawing from animal models and everything when it comes to something like stress, that is valuable. So I'm going to say, in fact, Amy, I think, is mixing up your typical academic's love of a science cover with a policymaker's need for something that is tried and true. Okay, so could the neuroscience of SES deliver actionable new information? Okay, warning. Rank speculation starts here. I'm going to just go through a few possibilities, knowing that, without a crystal ball, we don't know. But I think it's just useful to kind of expand, the space of possibilities that we're thinking about. Okay, well, so one thing is this SES moderation of brain behavior relations that I mentioned before. It indicates that there are different underlying processes involved with, like, Demir, Ozick Demir has shown beautiful work showing that higher SES kids do math problems using verbal parts of their brain. The better those kids do on the problems, the more left IFG activity they have, and there's nothing correlated in right parietal lobe. Low SES kids, the better they do, the more activity in spatial regions, the right inferior parietal lobe. nothing, no relation in the left IFG. So it looks like higher and lower SES kids, for whatever reason, are doing math differently. And I think one thing that implies is if you're designing like a math intervention or a math teaching program, and you find good results with high SES kids or with low SES kids, you probably don't want to immediately assume it's going to work with the other group, right? That was not known to us until the neuroscience. Okay. Biomarkers. Biomarkers for research, for screening, for prediction. These are very useful in terms of, teaching, screening, mental health, well baby checkups, et cetera. And it's especially important early in life where, presumably you can have the most leverage at ages when these babies cannot perform tasks. They cannot tell you answers. They cannot, sit at the computer and push buttons. So knowing what patterns of brain activity are associated with certain abilities, certain outcomes, could deliver valuable information. There may also be windows of opportunity for protecting and fostering brain development that make for a much more resource-efficient way of protecting the next generation of poor kids. Obviously, it would be nice if we lived in a world where you simply got resources for all families that needed them. So the kids were, breathing air that wasn't polluted, drinking water that wasn't polluted, nutrition, cognitive stimulation, et cetera, et cetera. But we don't live in that world. But wouldn't it be worth knowing if there is, let's say, 6-8 months prenatally, where changes that you make then could be very impactful? Do you want to put air purifiers in the homes of poor mothers who are carrying a child? The environmental differences between wealthy and poor are huge, and these are toxins that impact brain development. Farther out, and this is like in both senses of the word, there could be manipulations of epigenetics, because a lot of these effects have been found to be mediated by epigenetic changes. Manipulations of critical periods. Takao Hench and others can open and close critical periods. So maybe, if something doesn't go right at, learning to speak time, maybe you could get a do-over. I don't know, it's kooky, but I just think we have to begin to, begin to sort of play with ideas in this space. And microbiome, holy moly, the microbiome, as we have been learning, seems to be very influential in brain function. And there are clear, robust microbiome differences as a function of socioeconomic status. So, there's ways of changing the microbiome. I don't know, could it, would fecal transplants be helpful? Again, it sounds really kooky. But I just think, we need to be thinking broadly. Okay, So, conclusions. First of all, can neuroscience be put to use to reduce the harms of poverty? Well, there are some well-meaning overreach. There's some skeptical backlash. There's some fears about how the information could be used that would harm the poor. But there's no, we just don't know yet. There's no reason for pessimism. That is what I would say. The brain is the nexus of genes, environment, and experience, gives rise to cognition, emotion. There's no reason, that seems like the place to try to understand and improve. No guarantee that it is, but on the face of things, it seems relevant. I also want to say that, this is a young field, right? How long have people been doing neuroscience SES work? Maybe 20 years, not quite. How much of the research manpower in the world is directed to SES neuroscience? Minuscule. Compare this to autism research, right? I think, there's hundreds of millions of dollars in NIH funding going to this, not to mention private foundations and so forth. Lots and lots of labs focused on this for more than 20 years. Do we have cures? Do we have screening tests? No, but it seems plain to me that progress is being made. We shouldn't just say this is not working and call it quits. So I think with that as a standard to compare to, SES neuroscience is just getting started, and we need to play a long game. And okay, my PowerPoint says that's slide 26 of 26. So I think with that, I will thank you very much for coming and listening, and I hope to see you all at the reception.